Hello, my name is Gustav Krantz and I have something to tell you regarding the maritime fuel switch and emissions of CO2. As of January 2015, the shipping industry switched fuels in emission control areas to comply with stricter sulphur regulation. The previously so popular fuel oil was abandoned on behalf of gas oil. Several studies indicate only minor changes in CO2 due to the fuel switch. But I argue that that is false when you look at an holistic perspective. And in this presentation, I'm going to show you exactly how the indirect emissions occur and how they can be mitigated. Instead of looking at fuels and the shipping industry, I'm going to use a simpler analogy. And I'm going to use a very simple commodity that I think you're familiar with. So we're going to look at bananas, and these are not renewable bananas, these are actually fossil bananas. A banana causes emissions of CO2 of 100 grams in a life cycle perspective. But most of us have no use for the banana as a whole. We tend to be wanting either the berry, that is the inside of the banana, or the peel. In this model, I've decided that 50 grams of CO2 is emitted when we consume the berry and 50 grams are emitted when we consume the peel. We're going to look at two specific players in the system. First, we have the monkey that always eats the berry. Second, we have the pig that starts by eating the peel. Still, we satisfy the demand from the monkey and the pig and we will have a total emissions of 100 grams. Now, what would happen if the pig decided, I don't want to eat the peel anymore, I would like to eat the berry? So we switch this down here. I'm going to present you with three scenarios and afterwards we're going to try to capture some learnings from this simple model. First scenario is that we build a machine that can, at a cost of 5 grams, can transform the peel into a berry. Total emissions will simply be 5 plus 50 plus 50, so 105 grams in total. Second scenario is that we order a different kind of banana. This banana has a composition with 100 grams of the berry and only 5 grams of the peel. This will supply the demand from both the monkey and the pig with the berry, and we will also have a surplus of 5 grams of peel. But the alternative to decomposing or using the peel would be associated with some kind of cost. And if we cannot see, let's say, conserving the peel, and if we cannot detect anyone in the system willing to pay the cost for conserving the peel, we can assume that it is being combusted or emitted in the forms of CO2. Thereby, the total emissions in that scenario will also be 105 grams. The last scenario is that we simply order 2 bananas. This will satisfy the demand from both the monkey and the pig by having enough berries. And we will have a surplus of 2 peels. But same as in this scenario, if there are no player willing to pay money for conserving the peel or assuring that it is not emitted in the form of CO2, we can assume that it is being emitted in the form of CO2. Thereby, total emissions in this scenario would be 200 grams. That is, 1 banana causes 100 grams, so 2 banana causes 200 grams. Thereby, the fact that the pig switched food here from the peel to the berry has caused an increase in emissions of, we started with 100 grams and now we have 200 grams in this scenario. Still, if we were to measure around the pig, he would still only emit 50 grams of CO2. Same as the monkey, he would still emit only 50 grams of CO2. Why did it actually double in this case? Yes, has to do with this ratio here. Here we can see that half of the banana of the raw material goes into this high value product. In this case, we also have half of the banana that goes into this low value product. And if the pig, since the pig eats 50 grams of whatever he wants to eat per time unit, we simply, if we transform that one here, then we have to divide. We have to take 100 grams, which were the total emissions of one banana, and we divide it with 0.5. Thereby we will get 200 grams in total emissions. Now I'm going to link this model to the real life and to what has happened in the shipping industry and in the fuel industry. So instead of this banana, we have to think of regular crude oil, the crude oil that is being used right now inside these emission control areas where the sulphur directive has taken effect. Crude oil can be estimated to emit roughly 2.94 grams of CO2 per gram of crude oil that is being combusted, if we combust the entire raw material, so to say. But we don't do that. We tend to be wanting either one subproduct, what is called gas oil. A high estimate of an output from a refinery of gas oil would be 45%. Then we have to look at the peel, which is representing fuel oil in this case, the fuel that were previously used in the shipping industry, but they switched over to gas oil to comply with new regulation. The pig can be considered, well, the road transport sector or some other sector that uses gas oil or diesel also. And the pig is actually the shipping industry that switches. The switch has to do with the tighter sulphur regulation. So how much does the shipping industry use inside one of these emission control areas? An estimate from a Finnish study said that 13.3 million tons of fuel are being used inside this area by the shipping industry per year. These machines, they represent either what is called a hydrocracker, or which is a device that can transform fuel oil into gas oil in a refinery. Or it can represent something called a scrubber, which is an exhaust gas cleaning device you can install on ships. If you have a scrubber, you can still use the fuel oil and clean the exhaust gases instead. This bigger type of banana represents another different type of crude oil. So a different, let's say Nigerian crude oil has a much higher content of gas oil, much higher share of gas oil. If we could see that the refining industry had switched to a different type of crude oil quality, then we would detect it in this scenario. This scenario represents that the refining industry has increased crude oil intake, but they have the same shares of all oil products as before, so unchanged share of oil products, but they take in more crude oil and get more of all oil products out here, same as in our scenario with two bananas here. Now I'm going to prove to you that my analogy with the peel and the berry is actually true. On the left axis we can see the price of gas oil and fuel oil, which were the two fuels I was talking about for the shipping industry, and they are in relative terms to that of crude oil. So crude oil is 100% here in the middle, whereas gas oil is always more expensive than crude oil. Fuel oil is always cheaper than the raw material crude oil. We can also see here on the right axis we have the price of crude oil, that dropped sharply as of summer 2014. This picture will prove to you that we have not seen any of the scenarios 1 or 2. That is, we have not seen increased hydrocracking, or we have not seen a switch to another type of crude oil quality. Here we have the output from refineries near or in the emission control area of gas oil, and here we have the output of fuel oil. And in between here, measured on the right axis, is the gas oil to fuel oil ratio. And as we can see, as of October, this is a trend line starting in November 2014 going up to September 2016. And you can see that it is actually declining, so it's decreasing. That means if we were to have more hydrocracking or a different type of crude oil quality, this trend line would point upwards instead of downwards. So actually we have increased the share of peels per banana, oddly enough. And do we have any support for the 2 banana scenario? Yes, there is. We can see that crude oil intake in refineries near or in this emission control area have increased as of fall 2014. I'm not saying that it is because of the sulfur emission regulation, but it goes along with the sulfur emission regulation. I have 2 trend lines, one for this period and one for the period onwards. The difference per month at the end of these 2 periods corresponds to 2.6 million tons of crude oil. Per year, that would be roughly 32 million tons of crude oil. And when we combust 32 million tons of crude oil, we get roughly 93 million tons of CO2. Going about it another way, the impact of the emission control regulation as of sulfur has caused 13.3 million tons of fuel oil to switch to gas oil. If we estimate we have a 45% gas oil refinery output, and that if we combust crude oil, we get 2.94 grams of CO2 per gram of crude oil, then total emissions increase is 87 million tons of CO2 annually. Depending on how you measure, on where the baseline is, this would mean an increase of 145% due to this new sulfur regulation. If we look ahead, in 2020 the sulfur regulation will be global. That means all shipping will be affected by it, even though the sulfur limit is higher. If we have the same effect, that is the maximum effect that we can have by using the same method as above, would be, we estimate 250 million metric tons per year to be used in heavy fuel oil by the shipping industry. That would correspond to 1.6 billion tons of CO2 annually. And that is really something, because that amounts to almost 4% of total CO2 emissions. That is if you count coal and natural gas and all other types of emissions. So roughly 4% of CO2 emissions in an increase with 2013 levels. Ladies and gentlemen, I thank you for your time.